This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape Retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime Podcast. I'm your co-host, Dan Blewett. On today's show, got four really good topics. Number one, we're going to talk about GE working with LafargeHolcim on wind turbine blade recycling and mixing some of the shredded up wind turbine blades into cement, which is a really cool idea. We'll talk about a new tool called DARC that's going to help protect bats while hopefully keeping energy production up for some of these wind turbines with their curtailment solution. We're going to talk about this is my favorite thing of the week is the 1,000 foot, it looks like a huge box fan. That's potentially going to be an offshore solution. This new prototype said to be really, really powerful and can essentially take all this sort of swept area and put it into one sort of condensed package. And then lastly, we'll talk a little bit more about these prototypes, a GE floating prototype, and all that stuff in wind. Before we get going, I want to remind you that you can subscribe to Uptime Tech News. So if you're a regular listener to the show, number one, thank you. Number two, in the show notes, whether you're on YouTube, iTunes, Spotify, you can just check right below. There's a link, and if you sign up, you'll just get an email from us every Thursday saying, hey, we got a new episode. Here's some other great articles we found on the web, including the stuff that we discussed on the show. So if you want to stay current on what's happening in the wind industry, definitely sign up for Uptime Tech News. Again, link is in the show notes below. So Alan, how are you, sir? Let's get started with GE and cement. So we had, the founder of Cobod, Henrik Lund Nielsen, on the show, and they had a great partnership with GE and LafargeHolcim. Lafarge was providing the unique, concrete cement mixes for their 3D printers, which they're printing, wind turbine blade foundations and towers and all that stuff. I actually watched a pretty cool video. They built the first Habitat for Humanity home down in Arizona this past week. So a lot of good stuff coming out of LafargeHolcim. But they're teaming up with GE to potentially recycle wind turbine blades. And my big question for you here is, as an expert in composites, what does this mean for the strength of cement? I mean, it seems like this is probably a really good type of aggregate to mix into cement. Would it not be?
Yeah, it is. And there's been basically chopped fiberglass and even chopped carbon fiber, which is much more expensive, put into concrete mixes because it kind of binds everything together. It makes it like a concrete composite. That's what it does. So there's an advantage. There's advantages to that, and it looks like GE has completed for full circle now the recycling and reuse of wind turbine blades, from grinding them up to then taking them to a cement processing company maker that can use it for partially fuel, partial for reinforcement, and then 3D printing wind turbine blade bases, like the towers. They're going to print the towers, so they have a life cycle. That's pretty cool. That's the first that anybody's done that I know of. So it does. So not only you're using the wind turbine blades, but you're also making your towers, your next generation of towers, stronger. Which is a bonus, and probably less expensive because some of that chopped out wind turbine blade takes up raw materials that you would otherwise have to put into the cement mix, thereby making maybe possibly lower cost overall, which is
for your raw material. Yeah,
right,
that makes
right.
sense. Yeah.
You have your own raw material. Yeah, right, exactly. So there's just maybe a lower cost reuse that does make them at this point the industry leader in recycling. There's no one else close right yet. I don't think.
Yeah, well, and when we talked about Veolia recently, and that they have a solution that they were also partnering with GE. So,
Right.
I don't know the answer to this, but maybe all three of those companies are maybe collaborating. Again, I don't know that for sure, but we know Veolia has the technology to shred these blades essentially, and to help get them into that recyclable aggregate kind of form. So you'd think that maybe they fit into this since GE is obviously working with both companies. So
Right.
It's good to see these big companies teaming up to do what's important, because it seems like for a long time companies weren't that interested in what happened to their products
Afterwards.
after they were they're done. And of course
true.
that's still a big problem with soda pop bottles and a lot of these consumer single-use plastics. They're still not. So kudos to the wind industry for taking the initiative doing this when there's still lots of consumer products that are not.
Yeah, that's true. But there's also a financial incentive to do it now, right? And I think that's what's going to drive GE and Veolia and everybody else to go find out where the wind turbine blades are sitting right now and get them shredded, right? There's an incentive to do that. It's a financial incentive to do it. So they're going to start looking around trying to find those places where blades are stored, maybe even dig up the ones that they've already buried so they can recycle them, which would be just truly fascinating, because that is foreseeable. It's very similar to, this is probably pre-birth of Dan, so BD, I guess, before Dan, where we used to have aluminum cans. Like if you walk down the street at one point as a kid, there'll be like soda cans and crap and garbage. And one of the things they did was incentivize people to recycle aluminum. By aluminum had value, you could recycle those cans and get paid. And all of a sudden, all the aluminum cans just disappeared from the street because there was a financial incentive to recycle them. And it sounds like GE just made a way to incentivize operators, owners of wind turbine blades to recycle them, because you may get paid for them to take them away to grind them, which is better than burying them, that's for sure. So that's just really cool. It's a really cool system.
Well, and that does not predate me, because I'm pretty sure as a family we would like recycle some cans, and we would get to go to the recycling center. I can't remember how old I was, but I was probably pretty young, so it was exciting to collect 20 cans and get $1 when $1 was actually useful back then. When I was a kid, you get a box of macaroni and cheese for 49 cents, and so not that I was going to go buy macaroni and cheese, but and of course even maybe like a decade ago, and I don't know if I've seen anyone doing this, but you would see people in the streets, like you'd see homeless collecting cans, like fishing through the trash to get them out, and they would get money that way, which was also a good thing. Obviously a heartbreaking thing, but people knew, like, hey, this is, like, if I'm out here, I can collect this, and this is
money,
a resource for me. I don't know if that's still the case though. I don't know that I've seen someone do that, but I certainly noticed that in the past. Maybe that was when I was in Baltimore, what is it, 15 years ago, and out for college? Good grief. age. But yeah, and of course, was it Vestas who's found a way to essentially dissolve? It sounded like they're dissolving their blades and reducing them back into their.
Yeah, that was. I should have been prepared. No, that was
here,
a chemical process.
That's another solution.
Right, that's another process. Basically, break it back down into its elemental pieces and reuse them. Break down, get the fiber back out, get the resin system back out, and reuse the resin system again. That's a lot different. There's a lot of pieces to that. It makes it complicated, and I wonder how much financial incentive there is to do that versus grind it and sell it to another industry. Probably easier to grind it, sell it to another industry. Probably GE's pretty good about counting. The accounting groups at GE are pretty good about finding out where the money lies and how to make things work financially. I have a pretty good feeling GE's worked this one out.
Well, and you wonder. I mean, I think at this point it's good for everything to be an arms race, right? I mean, if there's three different ways to potentially recycle blades, and everyone starts getting on with the business of doing it, then you'll figure out, like, the cement thing actually is a lot more economically viable than the chemical reduction technique, if that's what you'd call it, or turning them into parts of parks, which we'd seen in the past. I think we talked about that over a year ago, that some parks over in Europe were using wind turbine blades chopped up and as like either art pieces or just as like a thing like to sit on into benches, whatever it was. But obviously there's going to be so many of them. you can't put them in every part,
yeah,
right?
That's true. And America has a slightly different issue than Europe in terms of wind turbines, because we tend to put wind turbine farms up in groups of 100 turbines, and Europe tends to do them in groups of 3, 5, 10. So when a park runs out of service life in the United States, there's a lot of blades, and we have just because it's easier to, America's a big country, so it's easy to kind of get them to and from where they need to go to get recycled. So there's a big problem. I think if you're GE and you put a lot of wind turbines up in the United States, that's going to be a big problem. It's going to be a big problem in the next couple of years. So they've obviously been working on it 3 or 4 or 5 years at this point. These things don't pop out of thin air. There's been a lot of work and engineering studies and accounting studies and agreements behind the scenes that we haven't seen, and we're just now seeing the very beginning of it. But these agreements have gone on for quite a while, which is really fascinating. It's been so quiet. So GE's known about this for a long time.
Yeah. So moving on, there's a interesting article from the from energy.gov talking about company Natural Power's DARC system, DARC, trying to just recover energy while protecting bats. So obviously one way to protect, animals, like whether it's birds or bats, would be to curtail the wind turbines, so turn them off, and then, they're going to be okay. But obviously that is a huge power loss. So this DARC system has a bunch of sensors. It can pick up using microphones the bat's ultrasonic echolocation calls, which is crazy and super cool. And then it can shut it down in 10-minute increments, which is obviously not going to be a huge power loss. So sounds complicated. Sounds really interesting. Sounds also somewhat similar to what the guys over at Ping are doing over in Australia with their acoustic monitoring. Alan, does this sound like a good solution?
Well, it's one way to address the concern, which is bats getting around turbine blades and the pressure differentials around the blades affecting the bat's very small, sensitive body and frame. So there has been a lot of discussion about, if we detect bats, what's the easiest thing to do? Well, the easiest thing to do from a safety standpoint is to stop the turbines. But there's been a lot of discussion about, past whatever time it gets dark, essentially when it's dusk, you might as well just shut them off and then turn them on the next morning. But that's a huge power loss, especially if there's no bats around some of the turbines for most of the night. So you're losing a pile of energy that you could otherwise be generating. Whereas if you were to detect them locally and then shut off turbines for a limited amount of time until the bats basically leave the area and get them back going again, you're just going to regain a lot of power you otherwise would lose. Remember, wasn't it in Ohio and wasn't it in Lake Michigan where they were talking, or was it Lake Erie? We're going to shut down the turbines at nighttime, right?
Yeah, I think Lake Erie. Mm-hmm.
Which is what you're trying to deal with, is how do you minimize the downtime without affecting the wildlife so much? And it seems like a pretty smart way to do it. I guess it really lies in the details how accurate the system is, and obviously when they install the system, they're going to be monitoring to see how well it does. All you need to do is kind of walk around in the morning and see how many bats are on the ground, unfortunately, but that's the way it's going to happen. But hey, look, it's better than not having wind energy at all, which is the other alternative. So there's a good compromise.
Yeah, it's just it's like a drawbridge approach, right? Like the bridge is going to be down and drivable most of the day, but you got to lift it up once in a while to let ships go through. So that's a lot better than just, like you said, not having a bridge.
Swimming.
Because there's too many big boats coming through. Yeah. So, and it seems like we have the technology to, like I said, I've never heard of that before, of them being able to detect their echolocation calls, but that is super cool. And it doesn't seem like bats are out there for forever, right? It seems like they're making their rounds, doing their thing, just like a flock of birds. Like they're not just lingering in the sky. So, maybe that seems like a good solution. So the big thing on the topic today, because this is my favorite new prototype, and I feel like there's more offshore wind prototypes like jumping out in the news cycle than ever right now. Like it's almost it's not even close to what's happening in aerospace with electric vertical and takeoff and landing vehicles, but there's definitely more of these because everyone's realizing, hey, we need more offshore solutions, and it can't all be inside the box with the standard horizontal wind turbine. But this wind catching system it looks like to me, just I see a huge like white box fan, like those cheap $15 fans that you put on when you spend your summer living in an apartment without air conditioning. And it's got a ton of smaller wind turbines in it. So just the nacelles and obviously the 3-spoke blades. But this thing, the scale is 1,000 feet tall, which is gigantic. And it's not, it's on 3 huge piles. But I mean, it seems, like that seems interesting. But Alan, what technical problems might they encounter with
first
this design?
one is how you're going to support it and what kind of infrastructure you'd have underneath it to support it. Second comes in terms of maintenance. I think how you're going to maintain the thing, which is really important because there's all kinds of maintenance on wind turbines all year round. Rarely do you have 6-month period where everything's quiet. So how are you going to maneuver around this large grid of turbines? No, it's not discussed, but I think that's one of the biggest issues is maintenance and repair. How do you do that? And say you lost one of the blades way up top, do you have to shut down everything else to get up there and repair it? As a worker, I'm not sure.
Yeah, that's a good question. Yeah,
I'm not sure I want to be around a lot of whirling blades on this superstructure, it just doesn't seem practical. It's one of those engineering things you see like, I don't think so. But who knows, right? I mean, obviously, they're going to have to make small prototypes and try them and to see how it scales up, which is the way you do things in engineering. Is start small, figure out all the details, and then just decide whether you can make it in full scale or not. I just think there's so many little details involved in power generation, particularly wind turbine power generation, that you kind of lose that. You lose the details when you're thinking on a grand scale, and it's the details that'll kill a project. That's just what happens.
Yeah, it seems like a lot of complexity, like you said, and that's to say there's 100 mini turbines on it. If one is down, do they go fix it?
Right.
If 3 is down, do they what's the threshold when they have to go and take care of it? Because you're right, if one in the center is down, I mean they've got to stop the whole thing conceivably to access it. And of course, the intricacies of this, it's not disclosed. It's just showing one rendering from one angle. So who knows? But yeah, obviously more moving parts is not better than less moving parts. But again, maybe they design hey, we could lose 15 of these, and we're still cranking and profitable, and that's fine.
Sure.
And then that makes okay. So they're just built in that whenever it gets to that threshold, we shut it down for 2 weeks, fix everything, and then put it back online, and it's still hunky-dory and profitable. So there's a lot, like you said, there's a lot we don't know. But the other thing is, we know that these wind turbines, they absorb the wind energy, right? So if you have a huge farm, there's less wind that comes out the other side. And so if you cluster all these together, are they collectively going to have less energy available to each one of them? Is that going to affect this?
The whole thing wasn't spinnable, right? It was like the individual turbines.
It doesn't appear to be.
It looked like the individual turbines could kind of pivot inside of this frame. That's what it looked like to me.
I can't really tell. It's tough.
Right, like a lattice work and a bunch of turbines inside this lattice work, which, again, it just seems like it's so far-fetched. It's on an engineering scale, is it worth it? And there's been a lot of really interesting, YouTube videos, like Engineering with Rosie is one of them, and then a lot of podcasts that are talking about some of the practical pieces of generating power, getting it to places where it can be distributed. And I just think it's so complicated. Right? That's one of the things that's happened over the years is that even though the wind turbines have gotten smarter, they've also gotten more reliable because they in some situations simplified them a little bit, and this is just super complex, and it just doesn't. Your engineering alarm bells start going off and saying, no.
We also wonder about the stiffness of it, right? I mean, this thing is 1,000 feet tall, and they're going to be absorbing a lot of this wind.
Yeah.
So these big gusts at 1,000 feet up, are they going to push this thing where it's like one little
Topple
weld
over?
pops and this thing starts to bend, or it topples over. It just seems like it has to be really stiff and well built,
Right.
much like a skyscraper. And it just at a glance at it, it doesn't seem like, again, this is just a rendering, but
Right.
it seems, I don't know, kind of exposed to the elements. But then again, who knows? And of course, we're going to have to see more of these. I mean, do you expect that we're going to see more and more of these prototypes, that everyone throws their own design and their hat into the ring to see what could be, what outside the box idea could actually work here?
Right. I think as offshore wind, particularly floating wind, becomes more of a reality than a vision, you're going to see just a bunch of different ideas pop up about how to best utilize all that wind, because a lot of times the wind offshore is very constant and reliable, unlike wind onshore where it can be up and down all day. Offshore tends to be a little more stable, so there's a huge energy resource just right off the shorelines. The question is, how do you best provide a stable platform and a means to collect that energy and to get it back on shore? And if you just keep your ear to the ground and just watch right now all of the different news articles and stories about different ways you're going to float these turbines, different ways you're going to be able to put them on ships or construct them out on the ocean. There's so many different ideas being floated, and each one of them has some potential. The question is, can they put together a business case and make it real, and couple that with all the infrastructure it's going to take to create these things, just to create the ships to haul the turbines to their final resting place is going to be a huge infrastructure problem. So while there's so many ideas about what these turbines are going to look like offshore and what the floating aspect is, all the detail and a significant part of the fortune you're going to spend doing it is going to be onshore, in terms of developing technical people, training them, creating the facilities, creating the infrastructure, creating a power grid to create the factory to deliver this, because most of these are going to be delivered from mostly remote locations that have had a dock in the past, and now they're going to revitalize this dock. So there's just so many other moving pieces. It's very similar to the aircraft industry, and is, interestingly enough, where the airplane is just a small fraction of the total cost. All the people and the infrastructure is so much more money than the final product. It's crazy.
Well, and you also wonder if further engineering efforts and prototypes are going to be aimed at capturing more wind and making more electricity, or if it's just going to be on hybridization, such as Siemens Gamesa just announced that they're going to try real hard to produce green hydrogen,
right? True.
From onshore wind turbines, and I'm sure that will become offshore as well.
Oh yeah, it will.
So, like, are they going to be like, no, we don't need to change the design of these wind turbines. Let's stick with what we have, but let's try to see what else we can do. Like, we've talked about the aquaculture labs and other different, just like ride-alongs, right? So you can have your 12 megawatts with a side of green hydrogen or a side of, whatever. I mean, do you think it could end up taking that route? I mean, where do you feel like...
that's a really good point, because I haven't really thought too much about the green hydrogen aspect. In the United States, you really do not hear any emphasis on green hydrogen. You hear it in Australia, you hear it in Europe quite a bit, and Airbus was just pushing back this week on green hydrogen and using it for bigger aircraft. But there are places where electrically generated hydrogen could be a useful piece of the energy portfolio. The kicker is, how do you make that into a business, and how do you sustain it? And in Europe, you may be able to sustain it, and it may be more of a reality, something that is worth going after, than it will be in the United States, where we're kind of electrified. We can do most things. And we're also very city-oriented in the United States, huge, massive cities. So it's just that's a very strange thing, because when you think about the wind turbine OEMs, for the most part, are in Europe, except for GE. I mean, even part of GE is in Europe, obviously, on the blades. But the way that the two countries and the economies are addressing these real problems is really different. Because I do think the green hydrogen does have a place to play, but it may not in the United States, at least not yet, which is weird. So then you have like two different business models going on simultaneously. And like Siemens Gamesa, which makes wind turbines for Europe and obviously the United States, is going to have to deal with both those simultaneously, which is a really weird place to be, because essentially you can be making two slightly different products to fit those marketplaces, which you don't like to do. You like to make one that goes everywhere. That's your ideal in terms of efficiency. So that is a really fascinating dynamic. I think it's gonna come up really quick. In the next 2 to 3 years, it's going to be a big deal.
Well, and maybe that's incentive for some of these companies to hitch up, because for me, a metaphor is kind of like, you know, if you're in spring training for the NFL and you separated all the veterans from all the rookies, well, okay, the veterans are going to do their thing, and the veterans in this analogy would be the standard wind turbines as they are, and the rookies would all be like green hydrogen. But then if you start to mix them together, now the veterans can like sort of nurture them along. So maybe if any of these renewable energy companies want to get heavier into hydrogen in the future, they could just like start kind of incubating it now by tinkering and like, let's see what we can do here. Even though this is maybe not a big player today, maybe it's a big player in 5 years. I mean, how many of these things couldn't we have predicted 5 years ago that were going to be big? I mean, Tesla's like exploded on, and that like the electric car revolution has kind of been quick. I feel like
it's kind of good.
You know, like there was no mention of it 10 years ago, and now it's all up in our face.
It was under the radar. I do think that's a very fascinating point, because the Tesla car thing is pretty obvious. You can count the number of cars that come out the assembly line. So you get quarterly numbers from Tesla saying they're making, I don't know, 50,000 cars in a quarter. The thing that I didn't realize was how many of those little power stations and recharging sites that they have built, which is in the United States, is thousands. They're everywhere. And there's been little fanfare about it. But if you were going to plan a trip to drive a Tesla from Massachusetts to Texas, there are a lot of places to stop and recharge a vehicle. And that infrastructure is just as important as the vehicle itself. And I think you raise a good point, is there's a lot of infrastructure stuff that has to be done that is just as important as the fancy, shiny automobile, that they have to go together, because the automobile without the ability to recharge it makes the automobile just not worth it. Having the recharging stations, which we've had in the United States for 20 plus years in a lot of places, locally, small onesie twosie kind of thing, but no cars to charge them, like with the Chevy Volt, and that just never happened. Yeah. They don't go together. So you need both to work together to get to that final solution, which is where I think green hydrogen and wind are going to go eventually.
Yeah, and that makes sense, because like you don't want to have, hey, we have 50,000 new electric cars, let's scramble to throw the charging stations all over the country. Like you want to just start, because you're right that they did sneak up, because I think everyone had that thought a while ago. It's like, well, there's nowhere even to charge a new electric car. Why would I want one? No,
at the grocery store they have recharging sites, places that you wouldn't think of. Libraries have recharging sites. They're everywhere. And it happens so behind the scenes that you never thought about it. But now when you go to buy a Tesla, they will make a big point of, well, there's 15 charging stations within 5 miles of your home. Yeah, cool. Right. That's awesome.
All right, well, that's going to do it for this week's episode of the Uptime Podcast. Thanks again for listening, and be sure, if you're regular here on the show, to check out the Uptime Tech News. It's a free email newsletter from us. Just lets you know when the next show is out, clips from previous shows, and again, other insider information from around the industry. Be sure to subscribe on iTunes, Spotify, YouTube, wherever you listen, and we will see you here next week. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.